What if the universe stopped expanding? Since Edwin Hubble discovered the expansion of the universe in 1929, humanity has always believed that this vast space is continuously growing, pushing galaxies farther apart at an astonishing speed. Even with the presence of mysterious dark energy, this expansion is accelerating. But imagine a completely different scenario. At some point in the future, the universe suddenly stops expanding. What happens next? Is this the final halt of everything, or merely the beginning of a new cycle? Imagine galaxies no longer drifting apart, but instead remaining frozen in place. Stars, planets, including Earth, could they be affected? Could gravity start pulling everything closer, leading to a cosmic collapse? Or is there an unknown force maintaining everything in perfect balance, creating an infinite yet unchanging space? In the universe, nothing is eternal. The cessation of expansion could signal an inevitable fate, a big crunch where the universe collapses into itself, or a permanent freeze where no energy remains for motion. But there is also a bolder possibility. This might just be the prelude to an unprecedented event, a quantum leap of the universe, initiating an entirely new cycle. So, what scenario might unfold? And could we survive these cosmic fates? Let's explore further. The reversal begins. A converging universe. Imagine a day when galaxies no longer drift apart. The expansion, which we once thought was infinite, suddenly slows and then completely stops. But instead of remaining still, they begin a journey in reverse, a cosmic convergence. For billions of years, the universe has been expanding, becoming more diluted, its temperature dropping, stars forming and dying in an endless cycle. But what if that process were to reverse? What if dark energy, the mysterious force driving the universe's expansion, suddenly vanished or changed its properties? With nothing left to counteract it, gravity would take control. Galaxies that were once moving apart would slow down, come to a standstill, and then begin moving toward each other. Slowly but inevitably, space itself would start contracting. Phase 1. The silent convergence. For the first hundreds of millions of years, this change would be almost imperceptible to an ordinary observer. Galaxies would still twinkle in the sky. Planets would continue orbiting their parent stars. The cosmic microwave background radiation, leftover heat from the Big Bang, would still be present, but subtle signs would start to emerge. The redshift, the stretching of light waves as galaxies move away, would disappear. Instead, astronomers would notice something unsettling. Light from distant galaxies shifts toward the blue spectrum, blue shift, indicating that they are moving closer rather than farther away. At first, this might seem like a mere anomaly, but as time progresses, it would become undeniable. The universe is contracting. Intergalactic gas clouds would begin to collide and compress. Galaxy collisions would become more frequent. The Milky Way, instead of moving away from its neighboring galaxies, would accelerate toward Andromeda and ultimately merge in a colossal cosmic whirlpool. Yet, this would only be the prelude to something much greater. Phase 2. A fiery spectacle of destruction. As the universe contracts, the average temperature of space would begin to rise. Aging stars would explode more frequently. Supermassive black holes at the centers of galaxies would collide and merge, creating massive gravitational waves that ripple across the cosmos. The night sky on Earth, if life still exists, would no longer be the same. The constellations, which once seemed eternal, would shift rapidly. Supernovae would become increasingly common, illuminating the night sky with violent bursts of energy. Gradually, there would be no more vast, empty voids in space. The universe, once expanding and cooling, would become denser and hotter. Nebulous gas clouds, instead of dispersing, would be compressed into fiery, turbulent regions. New stars would form rapidly but burn out faster than ever before. Entire planetary systems would be ripped from their orbits, plunging into the chaos of gravitational upheavals. If humanity were still around at this stage, we would witness rapid, violent changes within our own galaxy. Gigantic gravitational waves distorting space-time. Massive cosmic explosions lighting up the sky. Possibly the complete disappearance of our solar system, swallowed by a monstrous black hole. And then, the final act begins. Phase 3. The universe's brilliant death. As all matter converges, the universe reaches extreme density and temperature. Stars can no longer maintain their structure. Atoms themselves are broken apart under the immense heat and pressure. The cosmos becomes saturated with high-energy radiation, leaving no refuge from its fiery demise. At this point, all galaxies have merged into a single, dense, swirling mass of energy. Supermassive black holes devour everything in their vicinity, until even they are drawn together into one final, ultimate singularity. The entire universe collapses into a single point of infinite density and temperature, just as it once began. This is the Big Crunch, the final end of the universe as we know it. Is this really the end? But perhaps this is not the final chapter. Some theories suggest that when the universe contracts to its maximum extent, something strange might happen. A new explosion. The Big Bounce. The Big Bounce is a hypothesis that suggests the universe does not simply die, but instead it rebounds, like a compressed spring being released. This means that a new universe could emerge from the remnants of the old one, continuing an endless cycle of expansion and contraction, repeating over and over again. If this were to happen, perhaps we do not exist in a single universe, but rather in an infinite sequence of universes being born and collapsing again and again. And in this way, the universe would never truly end. It would simply transition into a new chapter. But what if the Big Bounce does not occur? What if the Big Crunch is indeed the absolute end? In that case, the universe as we know it would vanish forever, compressed into an infinite singularity, leaving nothing behind. Regardless of the outcome, the fate of the universe remains an unsolved mystery. And perhaps, in some distant future, if humanity still exists, we may be the first to witness that grand moment. The moment when the universe slowly contracts, returning to where it all began. But is there any way to escape this fate? Could we find a way to survive the collapse of the universe? A universe in balance. What happens if expansion stops? The universe once exploded from a tiny singularity and has been expanding for over 13.8 billion years. Under the influence of dark energy, its expansion has been accelerating, causing galaxies to drift apart at increasing speeds. But what if that process suddenly stalls? What if the universe neither expands nor contracts any further? In this scenario, the universe would not collapse immediately, but instead enter a temporary state of equilibrium. However, this balance would not last forever. Without expansion, a slow but inevitable process would begin, the gradual decay of all energy. And in the end, the universe would succumb to heat death, not a violent destruction, but a gradual, eternal fading away. Phase 1. The signs of decay. With expansion ceasing, gravity would not be strong enough to pull galaxies back together, but also not weak enough to push them further apart. Galaxies would continue to exist in their current positions, with little change in distance over time. However, within them, a critical transformation begins. The process of star formation gradually stops. Giant gas clouds, once the cradles of young stars, become increasingly scarce. Existing stars continue burning their fuel, but no new generations of stars are born to replace them. If our solar system still exists at this stage, it would witness the sun entering its final phase, becoming a white dwarf, a cold, lifeless remnant no longer capable of warming any planets. If Earth still remains, it would become a frozen, desolate world, devoid of life. Galaxies would still glow, but only because of the remaining stars. However, this would be the last remnants of a once thriving cosmic age. A bleak future lies ahead. Phase 2. Darkness takes over. After hundreds of billions of years, the last stars will finally burn out. With no hydrogen left to sustain nuclear fusion, each celestial light will flicker and fade. Massive stars will die in their final supernova explosions, leaving behind neutron stars or isolated black holes. Smaller stars will become brown dwarfs or white dwarfs, cooling down gradually over time. At this point, there will no longer be vibrant galaxies filled with starlight. The once dazzling cosmos will dim as the night sky becomes darker than ever before. Black holes will persist, but they are not immortal. Over time, they lose energy due to Hawking radiation, a process that is extremely slow but inevitable. After trillions of years, even the most massive black holes will gradually evaporate, leaving behind a universe with nothing but cold, scattered particles drifting in an endless void. Final phase: heat death, a slow but eternal end. As the last celestial bodies fade away, the universe will reach a state known as heat death. This is not a cataclysmic explosion or an abrupt collapse. Instead, it is a state where all energy is fully dissipated, leaving the universe stretched into infinity, cold and barren. At this stage, no new energy can be generated. No meaningful movement occurs. No physical phenomena take place. The remaining particles drift randomly, but they no longer interact, unable to form any meaningful structures. The temperature of the universe drops to near absolute zero, 273.5 degrees. Nothing can exist as we know it. No life, no brilliant stars, no shimmering galaxies, only an endless darkness where even time loses its meaning. Is this truly the final chapter? Although everything we currently understand in physics leads to the scenario of heat death, there are still other theories suggesting that the universe might not entirely come to an end. Some scientists propose that in this empty, frozen state, quantum fluctuations could trigger a new Big Bang, giving birth to an entirely new universe from the remnants of the old one. Others hypothesize that the fabric of space-time could break down after billions of trillions of years, leading to a new form of reality beyond our comprehension. There is also the possibility that a highly advanced civilization might find a way to manipulate the laws of physics, escaping this fate and engineering a rebirth of the universe in a completely different way. No matter what, heat death is not a sudden catastrophe, but a gradual and irreversible decline over time. If no physical phenomenon exists to reverse this process, then this could indeed be the end of everything. However, if something exists beyond our current understanding, a mechanism for cosmic rebirth, an infinite cycle, or a groundbreaking new physics, then perhaps the universe still has a chance to rise from its own ashes. A universe in transition. After billions upon billions of years, the universe no longer expands, nor does it contract. Space becomes a silent stage where all motion gradually loses its significance. As everything approaches heat death, some scientists believe this marks the final chapter. But what if the universe is not truly stopping, but instead preparing for a major transformation? An unknown physical phenomenon could emerge, shaking the very foundations of what we understand about space and time. The laws of physics that humanity has trusted for so long may no longer hold true when the universe reaches its ultimate limit. A new process could unfold, leading to a complete reorganization of the cosmos, or perhaps even the birth of an entirely new reality. Phase 1. When the universe becomes unstable. At first, there would be no clear signs that anything unusual is happening. Galaxies continue to float in the vast void, no longer moving farther apart, but also not being drawn closer together. Gravity still exists, but it does not create any major changes. However, after an extremely long period, strange phenomena begin to emerge. Light from distant galaxies no longer propagates normally, but bends into unusual patterns, defying standard gravitational effects. Certain regions of space become mysteriously opaque for no apparent reason, while others unexpectedly glow brightly despite lacking any visible energy source. subatomic particles, once stable for billions of years, begin exhibiting unpredictable oscillations. Some particles lose their mass, while others suddenly appear out of the vacuum. These occurrences suggest that the fundamental laws of physics governing the universe might be undergoing a profound transformation. Phase 2. When space-time itself begins to change. As the instability grows, space-time itself starts to exhibit unexpected behaviors. Radio signals from distant galaxies become distorted or vanish completely. Pulses of light from neutron stars become erratic, no longer following their predictable patterns. Some galaxies appear to shift shape over just a few million years, an impossibly short time on a cosmic scale. These anomalies cannot be explained by current physical models. Some scientists theorize that a new fundamental force has emerged, a previously unknown form of energy that alters the interactions between matter and energy. More radical hypotheses suggest that space-time itself is undergoing a fundamental transformation. Throughout the universe's history, space and time have been considered fixed backgrounds. But if the universe is preparing to shift into a new state, then the nature of reality itself may be changing in ways beyond human imagination. Phase 3. The cosmic transformation. After an extended period of growing instability, the universe seems to enter an irreversible phase. Black holes, once the most gravitationally dominant objects, begin losing their stability. Some black holes emit energy in inexplicable ways, while others seem to vanish without a trace. Large regions of space are stretched or compressed unevenly, as if an invisible force is attempting to restructure the entire universe. If previously, the expansion of the universe was simply the increasing distance between galaxies, now the very fabric of space itself is changing in unpredictable ways. At this point, two possible scenarios could unfold. Scenario 1. The universe reaches a new equilibrium. If the transformation is not strong enough to completely destroy the universe, it may stabilize into a new structure, where the laws of physics may differ from before, but still allow the existence of matter and energy. Scenario 2. A new Big Bang occurs. If the instability continues to grow, the universe could reach a point where space-time completely breaks down, leading to an event similar to the Big Bang. In this case, everything that existed before would be erased, making way for an entirely new reality with different physical laws. If the second scenario occurs, it would mean that the universe is not a single, fixed entity, but rather a sequence of rebirths, an endless cycle of destruction and renewal. If the universe is truly undergoing a transformation, the most crucial question is, can humanity survive this event? In the first scenario, where the universe finds a new equilibrium, humanity may adapt to the new physical laws and continue to exist in a world fundamentally different from what we know. But if a new Big Bang occurs, everything we understand would completely disappear. However, some theories suggest that if a sufficiently advanced civilization could find a way to escape the old universe before it collapses, they might discover a passage into the new universe at the moment of its formation. This could involve transferring consciousness or information into a new form of existence, freeing them from dependence on conventional matter. Nevertheless, all of this remains purely theoretical. For now, humanity can only observe the faint signs of a universe gradually changing. But if there is one certainty, it is that the universe has never been static, and even when it reaches its own limits, something new may still emerge. Whether the universe continues to expand, contracts, or settles into equilibrium, one thing is certain: we are living in a unique moment in cosmic history. What we know today may only be a small fragment of a much larger picture. Perhaps, future science will one day unravel the final mystery of the universe's fate. But what do you think? How will the universe end? Or could there be an entirely different scenario we have yet to consider? Share your thoughts in the comments. If you found this content interesting, don't forget to share this video so more people can join the discussion. And if you want to continue exploring more fascinating scientific questions, hit like, subscribe, and stay tuned for upcoming videos.